It's time to put to bed the fairy tale of dark matter. Something so dark, of course, it's invisible, and so mysterious that it remains undetected after decades of searching for it with sophisticated instruments scanning all the known cosmos and the entire electromagnetic spectrum. But how can something be falsified that's this imperceptible? Of course, there are many other invisible, non-existent astrophysical entities such as dark energy and neutron stars that have been invented and disseminated using disingenuous methods of measurement and interpretation onto a naive, unsuspecting public. But those are battles for another day. Being a scientist is like being an explorer who's attempting to hack a pathway through a dense jungle, snarl of weeds, vines, trees, and undergrowth. But the scientist's jungle consists of natural ignorance and also a lack of knowledge and grown false beliefs, which may be long-time officially accepted misconceptions. Real scientists try to produce hypotheses, that is to say, logical descriptions of real things and how they interact. All scientific hypotheses, of course, have to be testable. If it can't be actively tested, a hypothesis at least must pass the so-called test of time. Incoming new data has to fit comfortably into any proposed hypothesis or model without too much tinkering with it or massive back to the drawing board modifications. And certainly without inventing imaginary, illogical, non-measurable forces and non-observable entities such as strange matter to explain the new data. In the past few years, I've been studying Birkeland currents. Those are the strong, stable flows of electrically charged particles that connect from one place in the cosmos to another, what their form and structure is, and how they affect objects they connect with. Originally discovered by Christian Birkeland early in the 1900s, coming from the sun to the earth, they deliver the electric power that lights up our auroras. And I wanted to develop an accurate, realistic model of their structure. A complete description of what I did is thoroughly detailed in chapters 10 and 11 in my latest book, The Interconnected Cosmos, published by Stickman on Stone, and I urge you to pick up a copy. Anyway, here's a brief description of what I did. My starting point was at the edge of the scientific jungle, astrophysics and cosmology, which supposedly is the scientific study of cosmic space and those things that inhabit it. But it really is a jungle of contradictions and warped, bizarre, impossible processes and imaginary forces. But I had to begin somewhere. At that time, I had completed the derivation and interpretation of a mathematical model that had been started by Stig Lundquist in 1950. He had determined two equations that described the basic shape of the magnetic field that is inside a Birkeland current. But that's where he stopped. I completed his model to include 5 major equations and also interpreted what they implied about the physical shape of the Birkeland currents and their behavior. And that was not explained fully by Lundquist. My model predicted that Birkeland currents uniquely produce coaxial counter-rotational motion of their internal plasma and are able to carry electric current in both directions at the same time. Let me emphasize, this is a unique behavior. A coaxial cable here on Earth cannot simultaneously carry current in both directions. As far as we know, true coaxial counter-rotation is created in nature only by field-aligned, that is to say, Birkeland currents. For example, a pair of tornadoes located near each other, rotating in opposite directions, is not an example of coaxial counter-rotation, simply because they're not coaxial, they're not inside one another. So when NASA recorded those coaxial counter-rotating cloud bands on both Jupiter and Saturn, my model had passed its first test. That was the extent of my first foray into this cosmological jungle. And at that point, I figuratively pitched camp for a rest. But then announcement of the discovery of counter-rotating stars in the faces of several spiral galaxies was even stronger evidence I was headed in the right direction. In 2014, it was reported that a vast network of plasma filaments, Birkeland currents really, had been discovered that connects many, if not all, the galaxies in the universe in what has been called the intergalactic web, abbreviation IGW. The discovery was quickly confirmed, and a rush of scientific papers followed. All this strongly suggested that Birkeland currents not only connect objects within our solar system, but there are much larger and stronger Birkeland currents arching across the vast distances between galaxies. I assumed that those galaxies within the intergalactic web must be sending and receiving electric currents via the plasma filaments to which they are connected. Also, I thought if galaxies actually form on those Birkeland current filaments in the web, they probably inherit their rotational profiles from those filaments. If that happens, then the stellar velocity profiles ought to be the same as the velocity profiles of the Birkeland currents on which they form. Remember that the typical stellar velocity profile in a galaxy, a plot of the star's velocity as a function of its radius r, how far out it is from the galaxy's center, has been totally baffling to astrophysicists. Actually, they typically look like a plot of the function the square root of r. This shape cannot be explained by Newtonian physics, and almost all astrophysicists deny that electrical effects could possibly produce any of what we see in the cosmos. So that's why astronomers like Vera Rubin and her colleagues postulated the existence of dark missing matter in the 1940s. Their repeated unsuccessful attempts to explain this rotation of those stars is what set astronomers off on their decades-old quest to find dark matter. So I wondered if the plot of the rotation speed of the plasma in my model Birkeland current might be similar to the ones that baffled those astronomers. I set out to determine what that velocity profile might be. My model yields information about the magnetic field strength and the current density in a Birkeland current, but it doesn't directly yield any information about the velocity of the charges that make up those currents. The key to determining the velocity of the stream of charged particles in a Birkeland current was the realization that the current density in any plasma has two components: the charge density and the velocity of those charges. The charge density is how much charge you have per cubic meter, and the velocity, of course, is how many meters per second does that box of charges travel with. Therefore, if we know any two of these three quantities, J, rho, and V, we can find the third one. We obviously know from historical astronomical observations what the typical velocity profile of stars within a galaxy looks like, and it's approximately the square root of r. And we know from the equations of my model that the current density J varies with radial distance r out from the BCs, that is the Birkeland current's central axis, as 1 over the square root of r. So I was able to solve for the third quantity. Not very hard. The charge density rho that must exist inside my model BC, using all this data, the data from galaxy NGC 1620, it turns out to be a simple inverse relationship 1 over r. This clearly demonstrates that an electrical process exists that can produce the heretofore inexplicable stellar velocities that prompted astronomers to search for dark matter in the first place. In other words, the refusal to accept the existence and effects of electrical charges in space is what began and maintains to this day the dark matter wild goose chase. But is there any evidence that this particular distribution, this 1 over r shape, is the way charge really is distributed inside an actual BC? I took a short side trip off the logical journey we had been on to find that out. Did the velocity profiles of other galaxies also require this same charge density in the BCs they connected with? That was the question. Other galaxies may have slightly different velocity profiles. Using any of those other velocity profiles with the same expression for current density from my model yielded slightly different charge density curves. But the main point is that there is always some charge density curve that will exactly reproduce any arbitrary velocity profile. So I repeat myself. We have now shown, and as I said recently, presented in a greater detail in my new book, that a purely electrical process does indeed exist that can produce the hitherto inexplicable stellar velocities that prompted astronomers to search for dark matter. And that's the end of the story. The charge densities may be slightly different from that 1 over r shaped distribution in different galaxies, but the BC curve, the Birkeland current velocity curve, will always match the actual one. By the way, we know that BCs often show coaxial counter-rotation. So when we observe coaxial rotation of the stars in a galaxy that is connected to a BC, That's additional evidence that we're correct, that it is the Birkeland current that's producing the velocity of those stars in those galaxies. The twisting motions of the galaxy's Birkeland current are what produces the velocities of those stars. If we assume that the charge density distribution that exists within a typical Birkeland current filament is as a function of radial distance r, the distance out from the z-axis of the Birkeland current, is proportional to 1 over r, as it is for the one particular galaxy I show there, NGC 1620, we can solve mathematically for the electric field that particular charge density plot creates. In other words, we know what the charges are, where they are. We can solve for the electrical field that results. In turn, knowing the properties of that electric field allows us to find the voltage that will occur at every point within the Birkeland current's cross-section as a function of the radius value of that point. It turns out that under this assumption about the charge density, that the maximum voltage occurs exactly at the center of the Birkeland current at r equals 0, the central z-axis. Out from there, at points of increasing radius, the voltage plot is a simple, linearly decreasing function of r. This voltage distribution is exactly what's needed to produce Markland convection. Okay, but so what? What's Markland convection? Well, in Markland convection, it's a process that occurs in a Birkeland current. Atoms of the various elements present are sorted according to their so-called ionization potential. This results in the easily ionized, that is to say, the heavier atomic weight elements, such as iron, being found at the center of the filament, and the lighter elements, such as hydrogen and helium, being found in its outer regions. This process works because positive ions accelerate down the voltage drop that starts at the center of the Birkeland current and ends at its outer edge. They go faster and faster until they collide out at the edge of the Birkeland current with any matter, atoms, ions, dust, any other stuff. And this releases heat. Those collisions release heat. The temperature is hottest at the collision site, just at the Birkeland current's edge. And that's why the elements that are the most difficult from which to strip off an electron, such as hydrogen and helium, are found out there. So the center of the Birkeland current is its coolest region and contains the heavy elements, such as iron, and its outer edge is the hottest region, containing elements such as hydrogen. This is, intriguingly, the same sorting arrangement found in stars, including our sun, which are formed in Z-pinches in Birkeland currents. Our sun has a heavy concentration of hydrogen at its outer surface. Therefore, if the sun was created at the center of a pinch, such as a Birkeland current, then its center ought to be relatively cool, and its outer surface, the photosphere, should be quite hot. And it is. We know that the dark center of a sunspot, the umbra, is much cooler than the surrounding photosphere, and it's a window into the inside of the sun. But the question still remained, was my assumption that the distribution of electric charges, the charge density rho 1 over r, correct? Does it really occur? The answer came when a noted astronomer, Professor Michael Merrifield of the University of Nottingham, reported that the outer rim of a galaxy, this one was NGC 4550, mysteriously had a collection of counter-rotating hydrogen-rich stars at its periphery, at the edge of it. He complained that there was no known way for this to ever occur. His announcement unintentionally provided supporting evidence, and I consider it strong evidence, for my claim that a Birkeland current had been or was connected to this galaxy. This might easily have been the cause not only of the hydrogen-rich collection of stars along its edge, but also why that band was counter-rotating with respect to the other stars in NGC 4550. I assert that my assumption was thus shown to be valid, at least in this particular case. And once again, we see that an electrical process is the explanation that eludes all these expert astrophysicists that still say, yes, we know electricity exists in the cosmos, but it doesn't do anything. Well, the sun's heliosphere is a node, a pinch, in a Birkeland current. According to our model, the only place in a Birkeland current that involves energy loss would be the outer edge of the Birkeland current, where positive ions falling radially down that linearly decreasing voltage profile recombine with electrons just outside. This recombination process will emit a low level of visible light. It releases energy in the form of light. The newly formed energetic neutral atoms, called ENAs, energetic neutral atoms, then diffuse back into the Birkeland current. Being neutral, they're unaffected by any of the electromagnetic effects there. This visible light was discovered by the NASA Lockheed Martin IBEX mission. The announcement said in part, IBEX's all-sky map of energetic neutral atom emission reveals a bright ring of ENAs that encircles the entire heliosphere. David J. McComas, the IBEX principal investigator and assistant vice president of the Space Science and Engineering Division at Southwest Research Institute, said, quote, "The IBEX results are truly remarkable, with a narrow ribbon of bright details. This is a shocking new result," he said. "We had no idea this ribbon existed or what has created it. Our previous ideas about the outer heliosphere are going to have to be revised." But if history is any guide, it will not be revised. NASA and the astrophysics power structure never admit they were wrong about anything. We'll see what they do in this case. In any event, the Markland convection process may well be occurring all along the vast length of the Birkeland current that extends on either side of our sun's heliosphere. And that Birkeland current is not visible from Earth, probably because it's an aging normal Birkeland current that has a weaker charge density along its length than will be found at the Z-pinch, the heliopause, the heliosphere. The current density will be weaker. The plasma will therefore be in dark mode, quite likely, and I think it is from observation. And any light generated by recombination along its periphery will be even weaker than that observed by the IBEX mission. But the Markland convection process, in which the positive ions inside a Birkeland current are accelerated outward, directed by an E field from high voltage central axis, is exactly the same process that we now know occurs just above the edge of the sun's heliosphere when the solar wind positive ions coming from the sun recombine with incoming electrons to produce the light seen by IBEX. It's also similar to what happens just above the sun's photosphere, where accelerating positive ions escaping from inside the sun collide with other matter, which creates the high temperatures of the sun's coronal temperature anomaly. It's the same process, just with higher current density at the pinch than along the BC's length, and highest of all just above the sun's photosphere. So the evidence strongly indicates that stars are connected to their planets and to other stars. All galaxies are connected. The more we look carefully, the entire universe is interconnected by plasma Birkeland current filaments, and the electrical interactions at all locations are fairly similar, just with differing strengths and sizes. The process seems to be scalable. I have long wondered why cosmologists who claim the universe is created by a Big Bang explosion never try to explain where all the rotation comes from. Just about everything we see in the cosmos rotates or twists or spins. Why? How did it get that way from a Big Bang explosion? Birkeland currents rotate, and they counter-rotate. Is that the source of all the rotation? I claim yes, it is. At least until I hear of another natural process that can cause the rotation and coaxial counter-rotation we see everywhere we look in the sky. We all have to realize that no one can ever disprove the existence of something that doesn't exist. In order to maintain or renew the sources of their grant funding, astrophysicists who now refuse to put an end to their fruitless and wildly expensive dark matter quest are challenging us to do just that. In maintaining their assertion that dark matter still exists, they're saying something like, "There's a big vicious dog under this table. He's invisible, untouchable, unsmellable, and makes no sounds, but he ate my homework last night. Prove to me he doesn't exist." Now, this is a dishonest, illogical, unreasonable, childish challenge. Anyone seriously making such a demand is a shyster, a snake oil salesman who is intentionally trying to swindle his audience. Or perhaps he's an intellectually lazy astrophysicist spewing misinformation. Either way, the evidence is indisputable. The theory, and most importantly, the rationale for the existence of dark matter has now been systematically debunked. An accurate understanding of the cosmos is impossible in the conventional science of astrophysics simply because they refuse to expand their tool set. Limited to the force of gravity, in either its Newtonian or Einsteinian format, gravity only attracts. Magnetic forces can attract, but they can also repel. Electrical forces can also attract, and they can repel. And then there's the Lorentz force that exists between electrical charges moving through a magnetic field. including all of these essential forces of nature when cracking the secrets of the universe, then the concept and necessity of dark matter is outright ridiculous. Another key difference between the standard model and the electric universe model of cosmology